Well, what an amazing pleasure it is to be here with you. I just think it's fantastic to be back face to face, and I've got so much energy already from the conversations. And although I will say I've got a tough act to follow with both Tom and Jim's presentations, and I think what's really interesting is as Tom was speaking, I felt myself sinking deeper and deeper into the grief cycle as we reflected on our own digital journey, and we fully recognize all of those stages, the trauma, the anger, the frustration. And then I felt a little bit better because Jim gave us a little bit of therapy to make us all kind of emerge slightly from the deepest, darkest grief that Tom left us all in. And I hope that I might be able to share a little bit of what we've done. I want to start with a truest sense of humility here, because I have been chatting to a number of other companies, folks I've worked with, partner organizations. And I think the one thing I think we can all be honest about is that none of us have all the answers, and that we're all learning on this journey. And I loved where Tom started his journey with the email he'd sent to staff on C3, because I genuinely feel that we're at the end of the beginning. And that what's ahead is much larger than what's behind. And I feel that in Shell, we're positioned now to take advantage of some of that. And what I want to share with you today is a little bit of the learnings that I've taken along the way, and some of the things that I've got wrong, and also, hopefully, a few things we got right. And hopefully, out of that, we can help each other on our digital journey. And I want to start with three things. I talked about humility as the start of digital transformation. There are two other things I want to talk about. One is insight. And it's so important that you start your digital transformation with the insight of where your company is differentiated. And what are the things that you're good at? And I'll talk more about that in our context as we go through. And the final thing I'll talk about, so I talked about humility, I talked about insight, and I'll talk about respect. And respect is about recognizing where others are better than you. And I think there's something in that, and I'll dwell more on those points as we go through the presentation. And so it was 2020 when we were last together, and I stood on stage with a dear colleague and friend of mine by the name of Johan Krebers. Many of you will remember him. Johan was a great visionary and was one of the architects, really, of Shell's digital journey. And we talked together about two things, and it came up in Jim's presentation. We talked about two forces that we believe are shaping the world. We talked about energy transition, and we talked about digital transformation. Energy transition being the movement towards a lower carbon energy system, and digital transformation, I hope by now you're well educated in. My view is that these two forces, looking back on that presentation, are now more relevant than ever. In fact, those words, looking back to 2020, look rather prophetic, because no one could have anticipated the pace of change that would have ensued thereafter as we moved during the pandemic to fully virtual ways of working. And I believe that digital transformation has just been accelerated, and certainly accelerated up the boardroom's list of priorities. And similarly, on the C-suite table, since then, energy transition has risen right to the top of the agenda as the urgent and pressing need to move towards a lower carbon energy system has emerged as one of the largest priorities for all of us as corporations. And I would also argue, added to that more recently, the theme of energy security. Ladies and gentlemen, we live in a time of unprecedented change. And as we look ahead, everything tells me, going back to Jim's exponential curves, that the level of change we should expect in the coming period is going to be greater than that which we've seen to date. I'm convinced of that. And I'm convinced of it particularly in the energy sector, because anyone who follows LinkedIn, and I do, I'm sorry about that, will have seen that practically every company is making net zero pledges. What that means is they are committing to change the energy system as it operates today. Because for those that aren't aware, we ran a little experiment going back to 2020 where we stopped flying and we stopped driving for a while. And you'd think that would have an impact on global CO2 emissions. It did, about 6%. And if anyone ever underestimates the level of change required to truly transform our energy system, for me, that statistic sums up the scale of the challenge that we have in front of us. So where does the emissions come from? 37% of global emissions come from the heavy industrial sector. I'm quoting statistics from Bill Gates' book for those who haven't read it. Strongly recommend it. And I think the challenge is that in order to achieve those net zero ambitions, the level of change that we are going to have to go through in transforming the global energy system is unparalleled. And the only way that we're going to achieve that is through technology. And digital technology is one of the critical enablers, I believe, to help us go on that journey. You could argue it's one of the easier levers to pull in terms of its potential impact. And I hope that through today, I'll give you a window on how, at Shell, our digital technology and our energy transition ambitions are inextricably intertwined, and how we are trying to shape the energy system of tomorrow. We've made bold ambitions around our desire to lead through the energy transition. And it's something that gets me very passionate. We want to be net zero by 2050 or sooner in step with society. And we want to reduce our own emissions by 50% by 2030, basis the 2016 levels. These are very, very bold and ambitious goals for one of the largest energy companies in the world. In some ways, as we look ahead, we recognize that the energy system that's going to get us there is going to be inherently more complex, more distributed, and more diverse. We're going to see localized generation and small-scale production emerging alongside the centralized energy system of today. We're going to see new forms of fuel and new forms of gas being pushed through existing infrastructure in ways that we've never seen before, as hydrogen and biomass and renewable power take a much larger role in the energy system. And to manage a system as inherently complex, sophisticated, and diverse as this, it's almost impossible to think about a world in which data does not become a foundation for everything that we're trying to do. And so it's with that in mind that we've embarked on arguably one of the most ambitious digital transformations that there are out there. And I've got the scars along the way. I've made the mistakes, as I said. But we've made some good progress too. And what we've been doing in Shell is really putting in place the foundational capabilities that I believe are going to allow us to scale digital technology and are also going to allow us to manage that future energy system. We have been developing a foundational capability which allows us to take data from all over our distributed global business and integrate it into a common lakehouse architecture based on Databricks, as Tom mentioned earlier on. To date, we've aggregated 1.9 trillion rows of data in that centralized data environment. That's growing by about 20 billion rows per week, and it represents an aggregation of about 3 million sensors worldwide. That's not just coming from structured tables. It's coming from drones, it's coming from robots, it's coming from IoT sensors, and of course, from our traditional sensor technology, which has been available in our facilities for a very long time. And it covers almost every aspect of our business across upstream, liquefied natural gas and gas-to-liquids technology, our energy and chemicals parks, which are transforming refineries, and also our new energies business in renewable power generation. And it gives me great pleasure today to not just talk about this myself, but to actually bring along some of the people who have made this happen. And so you're going to see a cast of my colleagues who actually do the hard work. I just talk about it. And I want to demonstrate to you just how they're putting together the technology that I'm talking about. So the first of those I'd like to introduce is Bryce Bartmann. Bryce is the Chief Digital Technology Advisor in my team at Shell. And he's really been the architect of putting together this environment that brings together all our data. And so I want to invite him to the stage to show you exactly what we're talking about. Bryce, over to you.
All right. Hello, everyone. My name's Bryce Bartmann, and as Dan mentioned, I'm the Chief Digital Technology Advisor at Shell. My role for the last 3 or 4 years has actually been to get Shell's assets, data, connected to the cloud so that we can build applications and products on C3 that are not only reliable, but can scale across the business. As Dan mentioned, there are a number of parts of the business that we need to get these applications out to. We have invested in and continue to invest in the Shell Sensor Intelligence platform. A lot of the metrics that you're seeing here are actually based on that platform, which is how we take time series data from our assets and we connect it to the cloud. That comes from historians, OPC servers, IoT sensors, and also images and video that come from drones and robots, so that we can enable applications to run like we see on C3. Most of the applications that you're going to see in the presentation today are based on data that comes from the Shell Sensor Intelligence platform. All of you are here today to actually understand what AI and data science can do for your businesses, right? And these are truly exciting times for those opportunities and for you to explore how those can improve your businesses. But, and this is my opportunity to get this in, there is a big but to this. You need to invest in your data infrastructure to make any of these applications work. No one has ever said, my data science application runs great on terrible data, right? We've never heard that, and we never will. So we really need to invest in our data to make a success of what we want to do in this space. But I also want to warn you, please do not think that investing in data infrastructure means you have 200 data engineers sitting taking up floors in a building, just grinding through Excel spreadsheets, right? Shell Sensor Intelligence platform is based on about 12 to 15 developers that have scaled this solution across the entire business. So let's have a look at a little bit about what Shell Sensor Intelligence platform does today. So the first thing I want to show you is the operations application. This is what we use to actually create new requests for data coming from our assets into the cloud, and also where our operations can monitor those jobs. In this particular example, we're looking at a new request that's being created for you today, the C3 Transform 2022 demo. And what we're going to do is we're going to pick an asset. It's test data in this particular example. We want to stream some sensors that all start with the term SSIP, or they're all called SSIP. And you can get a number of options in Shell Sensor Intelligence platform. A, historical data to train your models on historical information. A daily extract if you just want to run updates on a daily basis. A real-time extract, which is streaming real-time data into the cloud that we can connect from C3 and use in our applications. The last is we can also extract metadata based on those sensors. What our operations team then does is able to look at this and use this to monitor all streams that are running across the globe for Shell. In this particular example, 126,000 tags or sensors are being streamed into the cloud that it can be connected to from C3 so that we can build applications that can infer information or value to the business in real time. They can also look at how jobs are running or processing as we go through our jobs on a daily basis. The next bit is just an example of how many jobs we are streaming in real time at Shell to satisfy all of our data science and AI kind of applications that exist today. The next thing that I want to move into is, we've got all of this data in the cloud. How do we actually make it visible for business users and data scientists to look at it? Ssip Studio is an application that also is running on our data lakehouse to pull data in real time that can be visualized. In this particular example, we're going to do univariate analysis of time series that is going to just pull some sensors that we've extracted in the previous example. We're going to run it on a month of data, and we're going to resample it in 5 minutes. These are all kind of things that you would do with typical time series data. It's running, connected to our lakehouse, pulled the data through, and plotted it in real time for our users. The next thing is just to try and make this as commercial grade as possible. This is our documentation site. This is where our business users will come to be self-enabled, to be able to understand how does Shell Sensor Intelligence Platform work, what are the capabilities, and what else can they do? Things like we also have a Python SDK that our data scientists can use to connect and query our data in less than 4 lines of code. I hope this gives you some insights as to how Shell Sensor Intelligence Platform works, what we have done at Shell to invest in data infrastructure so that we can succeed, and lastly, to just say that Shell Sensor Intelligence Platform is a part of the OpenAI initiative. Thank you, and back to you, Dan.
Thanks, Bryce. And I hope that gives you a sense of the sheer scale of what Bryce and the team have built and just the engineering prowess that they have. I'm always truly blown away when I see all of those streams running in real time. Of course, many of them connecting into the C3 platform, as Tom talked about earlier in the way in which we're integrating our architecture. And maybe that's where to go next. What I wanted to talk through as we build on that is that, of course, that's just getting the data into the cloud, making it accessible, as Tom said. It's an enabler, but it doesn't solve the problem. And so what we're then trying to do is then trying to integrate those data sets, augment them, and make them more accessible. Firstly, to give them context, and then also to develop AI applications that can predict, can correlate, can classify, and can start to add value and augment that data in real time for a variety of different business use cases. And what I'm going to talk through over the next few minutes is really how we're doing that by combining technology to create an integrated digital architecture. And just to give you a sense of the scale, we've got about 49 different developers that are developing C3 applications today. Those are Shell folks, and obviously we have support from C3 and from partners on top of that. We also are deploying, as Tom said, applications to about 23 assets worldwide. That's AI applications in production. We've got about 100 AI applications that we're developing, or AI apps, I should say. Now, interestingly, we have about 10 AI products that we're developing and 4 AI products in development. You might say that might not sound like a lot. And I want to take you back to Tom's presentation earlier on, because this is one of the key learnings that I want to leave with you. What we've found as we've gone through is we started off building AI apps. In other words, algorithms that provide insight, that allow businesses to take a specific action. And we deployed them through MVP deployments in many different parts of our business. And they delivered value. They were very powerful in terms of helping us to develop our digital journey. The problem is that if you keep building AI apps, you end up with lots of them. And lots of them are hard to support at scale. And so what we're doing is that we've worked with our businesses to really understand what are the areas of the business that we want to see transformed. And then figuring out what are the AI products that are going to help us transform those things. And then how do we integrate AI apps as features into those products to enable us to scale. You see, there's a real truth about AI that isn't commonly understood. And it goes back to what Tom was saying. The real value in AI is the business outcome. And the business outcome is driven by the fact that you transform where and how work gets done. Say that again. You transform where and how work gets done. In other words, this is business process re-engineering, which is where I started my career. I think Jim will remember that from his SAP days. This is business process re-engineering revisited. Only now, the technology is there to really do it. And so what we're doing at Shell is we're rethinking the way in which business process gets put together. And let me give you a couple of real examples and also talk through some of the value impact that we've seen emerge from that. And I want to start with proactive technical monitoring. A few years ago, we had the foresight to realize that one of the ways to improve our assets and the reliability of our assets, which is something I know many of you will recognize, is that we could look at remote surveillance capability to start to identify issues before they happen by having remote engineering teams, digitally savvy remote engineers, looking over the shoulder of the asset sites and identifying where things could go wrong and providing those insights back to the folks at the front line to help them to do their job. Like I said, we call this proactive technical monitoring. And if you want to talk about impact, the collective transformation of that within our upstream business has led to a 5% increase in reliability over the last 5 years. Put that in perspective, that's 100,000 barrels of oil equivalent per day. And I'll let you do the maths. The key point is that's the outcome. Now, is it a digital outcome? Kind of. It's a business outcome. It's driven by business process transformation, changing the way you work, refocusing the front line and how they operate, enabling them with digital capabilities. All of that comes together to achieve a business outcome. Can we point to outcomes from the digital capabilities? We can. But because we're finding small and fixing small, it's hard to quantify that. However, in 2021, we were able to say that that process, proactive technical monitoring, delivered about $150 million of bottom line impact across our business just by the findings, the validated findings that we've identified. That's a significant amount of money. And so what we're also doing, and this is where the AI comes in, is that we're now able to infuse that process with AI to further accelerate the ability to predict and identify issues before they happen. We've deployed over 10,000 we're monitoring over 10,000 pieces of equipment every day in real time using AI embedded into our proactive technical monitoring process. That's one example. Let me give you another. The flip side of proactive technical monitoring is optimization. And we've been working for a long time to develop a product which we call Shell Process Optimizer for LNG, which we're using to optimize the performance of LNG trains. And again, coming back to my theme of partnership, we've been working with our colleagues at NLNG to develop this solution and to deploy it in a multidisciplinary team with the NLNG facility. My engineers working remotely, working directly with the folks at the site. The impact of that we've seen has been a 1% to 2% increase in production for that facility with no additional capex. Even more importantly, we also project that the CO2 emission reduction associated with the deployment of that set of algorithms, which is based on monitoring the overall process variables, the temperature, the pressure, the flow rates, and then adding to that the constraints, understanding the engineering constraints, the safety constraints, the economic constraints, and then optimizing the performance of that process, the CO2 impact of doing that, projected at full capacity, is around 130 kilotons per year. Now, that's the equivalent, for those that aren't familiar in CO2 metrics, in removing 28,000 standard US vehicles from the road in one algorithm. That's the sort of impact that AI can have when deployed at scale across a business. And we're just getting started. Because as I said, I believe this is the end of the beginning, and the future is ahead of us. We're developing solutions which are looking at how we can combine satellite technology with drone technology and sensors at site to monitor greenhouse gas emissions in terms of methane and CO2. We're developing solutions to embed sensors into engines to monitor the performance and identify anomalies based on AI that detects issues in the lubricant based on all of our historical experience in lubricants testing. We're developing AI that can optimize the configuration of a future energy plant. You see, we see the potential to both make our existing business more effective and efficient using AI, as I've shown in the examples, but also to use AI to design the energy system of the future and to operate it once it's there. And this may sound like science fiction, but actually everything I've just said is based on real-life projects that are happening in Shell today. And I'm going to disagree with Tom for once. Because Tom talked about digital twin. And one of the things I firmly believe about digital twin is it was the right idea talked about far too early. You see, what I'm talking about a lot is the energy metaverse. In other words, I believe it's now possible to put together an integrated vision of your asset, which is a digital copy of the physical reality. We have all the data to do it. Bryce just showed you that. And we're now integrating three-dimensional drawings, P&ID documentation, transactional data from SAP, and also three-dimensional scans of our facility into an integrated digital reality, which we're rolling out globally across our business. That gives you a data foundation. It doesn't solve the problem, but it does help those digitally savvy remote engineers to understand what they're looking at. The future, however, is the AI metaverse. And what I mean by that is the AI-infused digital twin. In other words, can you take the physical reality? Can you simulate? Can you optimize? And can you then re-engineer backwards into the site the optimum configurations? And I believe this is possible. And I believe it's possible because I've seen it. And today I'm going to give you the privilege of seeing where we've got to. So I'd like to invite to the stage one of the digitally savvy engineers that I was talking about, so you believe me. And I'd like to invite Justina Zollner to the stage. She's been an amazing advocate for this, and this is about making her life easier as she seeks to improve these processes. Justina, over to you.
Thank you, Dan. Hello. My name is Justina Zollner, and I work for Shell Technical Asset Operations, which is engineering centralized organization supporting our assets in many areas. One of such areas is Predictive Maintenance program, which is where we use C3 machine learning models to detect degradation for critical equipment like compressors, turbines, pumps, and control valves. I am a remote engineer for this program, so I develop models, I analyze alert, and I notify asset about potential problems. To build a model, I need to understand the machine. The more I know about machine specific, the better model I can build. This means that I need to collect and analyze data which are dispersed in many systems. So as you can see, after machine is selected, I need to review a lot of technical documentation. I need to understand the process. Every machine is different and has its own specific. We work for different assets, and we quickly onboard ourselves in the machine. In industry, there is never enough time to do the job. So as you can see, I need to analyze data to select proper inputs for my models. I need to understand how machine is instrumented. So I need to collect tags. And this means sometimes even that I have a list of 1,000 tags from which I have to select my key 50, the most important features for my model. And to do it currently, I'm using at least 3 systems. And I'm comparing manually the data. I need to understand what happened to this machine in the past. So at least 2 systems to analyze the events in the past of this machine. And I need to review historical data. I need to review if the instruments are healthy, and I need to understand what is the proper behavior for this machine, because this is machine specific. So as you can see, the process is complex and time-consuming, so we are looking for improvements. And coming back, the digital twin is a real game changer here, because digital twin replicates features of the physical object into virtual environment. So it centralizes data. For me, it means that data are that I consume less time for searching inputs. And this is great basis to build on. And because the data are centralized, but we need more. The reality is more demanding. We need to efficiently manage the data. So we've built on this in two directions. We have implemented semi-automated task selection, and also we have implemented integration of systems. So here you can see how the new process looks like. I am in C3 now, and I need on the left side list of tasks to build my model. So I go only to digital twin, and the list of tasks is already waiting for me, for my approval. I can efficiently check all inputs. I can see how trends look for the task, so I can see if the signal is healthy, if it's proper. I can see what's the role of this tag in the process. I am guided directly to the area of PNID I do not need to look for. And I approve predefined tags, or I can reject them. If I believe that I need more tags, I can quickly add more tags to my list. When I am already happy with my list of inputs, I come back to C3. And here I'm describing the second part, so integration of systems. I am here again in C3. I have all tags, and those tags are linked with digital twin on the tag level. So I can quickly go back to digital twin if I need to check something. This is especially valuable when I analyze alerts. Here you can see also asset engineers' needs addressed, because they want to know how we are progressing on PDM and how machines are doing. So here is a digital twin interface when there is a dashboard for C3. So asset engineer can see what machine are under our surveillance already, how many alerts per machine is there. They can segregate alerts by status. They can see location of machines on the plan, and if they want to check one particular machine, they are going into details mode when they can see specific situation for the machine. So you can see here all key story of alerts for this machine. And also to understand the situation of the machine, asset engineer can review notifications from other systems. What happened to this machine recently? So as you can see, this new process enables us to save modeling preparation from 2 weeks to just 1 day. And this is really something really valuable for us, because it addresses our needs and asset needs. And we have already 500 machines defined in our scope, and this number is growing. This is digitalization for engineers. This is the type of automation which is removing waste, but still we have control on what we are doing, and we can make decisions even with better confidence than before. So from end user perspective, from my very personal perspective, I can say that this was absolutely great experience, because two suppliers of the system knocked to me asking what our system can do better for you. And this is absolutely amazing. And there are always something else to do, right? Because the reality is demanding. And the one common answer, I believe, is always to make those systems cooperating. I'm reporting my personal experience. When my systems start cooperate, value of each of them multiplies. And this is the deal where everybody wins. This is right approach. We are building on this. And what we achieve is up to us. Thank you very much. Over to you, Dan.
Brilliant, well done. Thank you very much, and I just think seeing that is absolutely amazing. And I truly believe it's a vision of the future. Having that integration in one environment with AI being driven by the digital twin and the AI feeding back into the twin, providing full integration, I believe is transformative in terms of what we can achieve. So I promised I'd take you into the AI metaverse, and we're now going to go deeper down the rabbit hole, because what you saw there was just the time series data. I talked about robots and drones and starting to automate the inspection processes across our facilities. You see, we're already, as you see on the picture, deploying these ATEX certified robots, which are starting to manage inspection processes on behalf of our engineers, removing people from the environment and improving our safety performance. These robots are doing simple tasks already across our facilities. They are reading gauges, they're identifying lubricants levels, and they're starting to do things like sniffing out very small fugitive emissions and flagging them back to the sites like the one in the Energy and Chemicals Park in Pernis. And we're trying to then build that out to provide even deeper capabilities. One of the areas that we've been really excited about is the ability of these robots and drones using machine vision to identify corrosion and damage across the facility. And we've developed a product called the Autonomous Integrity Recognition System, which allows us to identify issues right across the facility in real time, and then to integrate them with our inspection management system. Some of you will have seen that yesterday we announced a new collaboration talking about system integration between C3 and Sonosco as part of the OAI, where we're now embedding C3's AI capabilities into our inspection management system. And I believe this is an absolute game changer as we seek to integrate the output of robots and drones, as well as static cameras and time series data, directly into inspection management to transform the inspection processes across our facilities. And so to talk about this, I want to invite to the stage Susan Burrell, who's going to give a brief demo of what we're talking about.
Good morning, everybody. Nice to be here. My name is Susan Burrell, and I was responsible to develop Shell's predictive maintenance products. But because my colleague can't be here today, I'm presenting to you AIR, our Autonomous Integrity Recognition System. Just imagine we have an onshore plant, and we have millions of kilometers of pipe, millions of flanges, and imagine the effort, time, and cost to inspect and maintain these facilities. And that's where AIR comes in. AIR's ambition is not only to provide consistent and good information on the inspections, but also save costs for inspections, scaffolding, maintenance preparation, improve our maintenance planning, but also keep our people safe, all in an end-to-end system. We capture images, and these images come from drones, pole cameras, robotic crawlers. As long as they comply to minimum standards, we can use these images. As soon as the images are uploaded, the machine vision kicks in. It identifies issues, which you can see on the screen here, identified by small frames. And the remote engineers can pick these up, accept the issues, modify, or reject. All of this is integrated, as Dan mentioned, into our integrity management system. Here, the images are presented, but also the engineers can pick it up, view the model of the asset in 3D, look at previous history. They can also look at images that were previously recorded. They can write new reports and track actions. It is a very substantial system that we have developed that really improves the ability of our remote engineers. But you think, okay, this is all very well. What do we do? This is now, but we are thinking on how do we take this to the future? We are thinking this is not just about identifying needs for inspection, but we want to be able to provide controlled actions for exactly the same system so that we clearly talk about a semi-autonomous plant, really the path to our future. Thank you for your time, and back to you, Dan.
Thank you very much. So I want to close with this, and I want to talk about the importance of the digital ecosystem. And Tom already alluded to it. But actually, a lot of the benefits is around integrating systems, as you've seen from the demonstrations that we've seen today. A year ago, we launched something which we called the OAI. The OAI is a collaboration between ourselves and Baker Hughes, C3, and Microsoft, which were the founding partners in that. And what we're seeing now already is that we are starting to not only develop these solutions ourselves with our partners, but we're seeing our partners come to us with innovations as part of this open ecosystem that are helping us to further develop our technology. A recent example is a fantastic integration that Baker Hughes has developed together with C3 on System 1, where they're starting to integrate that technology with condition maintenance as an industry standard developed by System 1, now augmented with AI. And we're now testing that capability at our facility in Geismar. And so you can see that as we collaborate and as we work together with humility, with insight, and with respect, we can actually start to work much more quickly and to accelerate our digital transformation. And so what I want to talk about briefly is just the fact that we're starting to see this accelerate at scale. We've seen a number of different companies joining the OAI, and there's many more to come. And if we want to transform the energy system, and we want to shape the energy system of the future, I'm firmly convinced that the only way we're going to be able to do that is if we work together. We at Shell are firmly committed to playing our role in helping to accelerate digital transformation in support of energy transition. And it's in that spirit that all of the things that you've seen today, we've actually licensed back to C3 and made available to the market. And we hope that others are going to do the same, because we want to see the capabilities that you're building out available to us so that we can accelerate each other's journey. The world needs more and cleaner energy solutions, and we need it quickly. And I believe the only way that we're going to do that is through technology, and digital has a critical role to play. I look forward to partnering with many of you on this journey. Thank you very much.